talked about orthogonal projection, and we have a nice theorem. The theorem says, hey, if you think about orthogonal projection, the distance between the vector u and the projection of u over v is always less than the distance between u and any scalar multiplication of v. Okay, let's continue the orthogonal projection, make it more interesting. Let f of x be function 1 and g of x be function linear function x. And v be the space of all continuous functions over 0 and 1. Question says, find the orthogonal projection of f onto g. Projection of f onto g. Very good. So recall that the inner product that we defined on C of a and b is the definite integral a to b of the multiplication of the functions. Remember this inner product. Now, by definition, the projection of f onto g is the inner product between f and g divided by the inner product between g and g times function g. So let us begin. So on the numerator, you have the integral 0 to 1 times x dx divided by integral 0 to 1 x squared dx, and you have function g, which is x. This should be easy for you to compute. The projection of f onto g is equal to, here you have a half x squared 0 to 1 integral a third x cubed 0 to 1 times function g, which gives you a half divided by a third times x, or 3/2 times x. So the projection of function f onto function g gives you a linear function 3/2